Hello, my name is Kevin Gary. I'm the Program Chair for Software Engineering and the Course Coordinator for SER316, the Software Enterprise, Construction and Transition. This course is named for a phase in the rationally unified process, two phases in the rationally unified process for construction and transition. It's the emphasis on your development skills in producing software that is what we call production ready, ready to go out as a service or as a product for your customer. As an enterprise course, we teach in context. So the principles that you learn, the techniques that you learn are done in a project context like the rest of your project-centric courses. That's part of our project-centered spine. As a junior level student, which is what this is targeted for, you're expected to have also be taking courses related to operating systems, distributed computing, perhaps databases, starting to work into your upper division. So these are mature coding practices that were intended to see you integrate and apply throughout the rest of your degree experience here. I came up with this course years ago. I'm the original author of this course going back a ways now, at least a decade. And the origin of this course is when I went and worked in the industry, I had a number of junior developers on my team. And they seem to know all the individual practices, but not necessarily how to apply them in context in the real world. So you'll be taught explicitly how to work through struggles in teaching or applying the theory, if you will, into a common practice, and what trade-offs you go through and what decision-making processes that you go through. So I'll talk about course outcomes in a minute, but we'll talk about, in addition to just the technical skill of learning a tool or a practice, you'll learn some of the experiences, if you will, of how to apply those, and that's the intent of this course. The foundation for this course is Agile methods. And I say Agile in the broad, there's some Agile specific processes, and two of them are particularly relevant for this course. The first one is Scrum. You'll work in a team-based project using the Scrum methodology, meaning you will work in iterations or what's called sprints. You will work through a product backlog, you'll work through a sprint backlog, and you'll learn how to construct the backlog, fill it up with user stories, how to track your progress through burn down charts, how to work in continuous integration and testing, how to measure your progress, and so forth. On the developer side, the specific development construction processes that you'll learn are taken from something called extreme programming. Extreme programming is another Agile method, and it's very related to Scrum. It still has an iterative philosophy to it. But XP spends a lot more time talking about specific developer practices, or what's really been software engineering practices that have been around for a long time, but are adapted to the Agile way of thinking. So for example, you'll do code reviews, and code reviews are a traditional technique in software engineering, the foundational work done in the late 70s. However, from an Agile perspective, they've evolved that into something called pair programming, saying if code reviews are good, let's do them all the time. Let's do them in real time as you write code. The same thing for things like static analysis, unit testing, and so on. So you learn a collection of different techniques on a particular cadence, meaning you might go in 1 week on a particular module and learn about unit testing. The next week might be static analysis. And then you'll be asked to apply those in the context of a scalable code base and a scalable team project in that next iteration, in that next 2 to 3 week period. So it's a just-in-time type of contextual learning model. The prerequisites for this course, now these have changed some. Currently in the program, it requires SER315 as a direct prerequisite. We are relaxing that prerequisite starting in the fall of 2018. And students going forward will only be required to take SER222, Data Structures and Algorithms, and SER216, the Precursor Software Enterprise course for sophomores. 315 will not be required, but we strongly encourage you to take them in sequence. So if you can take 315 beforehand, if you're on an A-B split or a fall-spring C-session split, we still advocate that you take these courses in the 315, 316 order if you can. We do think that's beneficial, but we have relaxed the prerequisite in case you require some flexibility in your course planning. Course expectations. This is lack of a better term, this is a gauntlet style course. This is a course that requires a lot of your time and a lot of work. It's a little bit of a trial by fire experience. This course will take a lot of time because there is a lot of coding. As a construction course, you're being taught how to write better code. And to do that, you have to spend time with existing code and make it better, and you have to learn what that means. as that programming style course, in that construction course, using a lot of these techniques, expect it's probably going to take more time than the standard course. The typical course model at ASU is 2 to 3 hours of outside work for every credit hour that you take. In this course, expect it to be 3, 4, maybe even 5 hours per week. You're looking at 12 to 15 hours per week for an on-campus student and double that for an online student outside of course time to do the teamwork and to do the individual construction labs that are involved. So please plan your schedule appropriately. You will be busy. Another thing is you have to keep pace. As I just mentioned a little bit ago, this works on this very iterative philosophy, this notion of a sprint. You're learning individual techniques a week at a time, and then you're asked to apply them in the project in the next iteration. So it's that just-in-time pedagogical model, all right, an active learning model that we base this on, which means you can't learn a technique in the beginning of a semester and then 10 weeks later expect to apply it in the project. You expect to apply it in the next iteration, pretty much right away. So within a month's time, some technique you hadn't heard of, you'll be taught the theory of it, the practice of it, you'll do a lab on it, and you'll be expected to incorporate it into a project and then reflect and tell us what you think about it. So that means you have to keep up. You can't defer and put that work off till later and still be successful. So very important to not get on the wrong side of the slippery slope in this class. The key to being successful is to keeping pace with the class. In terms of the course outcomes of the class, there are currently 5 that are listed supporting our degree program outcomes. First one, students will learn techniques for producing high quality software code, production ready code, including source code documentation and unit tests. That relates to our software engineering practice and technical competence degree program outcomes. Students will learn techniques and best practices for transitioning software products for release. We have a value, a philosophy here in the program. It's not about just getting it working on your laptop. It's not about writing a lab for school. We're trying to train you to how to write production-ready software, software that's ready to be used out in the wild, if you will. So that's another software engineering best practice technical competence. As an aside, I'll say, again, our goal here isn't to just write code to get it working. It's to write code that's maintainable, is highly performing, is understandable, and all those abilities about software engineering, and put that into practice. Course outcome 3, students will learn to assess the quality of existing software, understand its structure, and understand the risks of leveraging such software for a desired solution. What this means is you're going to be working with existing code bases already. You're going to start with what will seem to you to be a lot of lines of code already and have to understand an existing system. And you'll also have to learn how to evaluate software that you can get on the market, either open source or what's called commercial off-the-shelf software, or COTS software. When you are asked to build new features and meet requirements in a system, you often build that yourself, but very often, more often, you go out and you look for somebody who's already solved that problem and see if you can use or adapt their solution. And part of that is a technical evaluation. Part of that is a business evaluation, if you will. Do I have the licensing constraints? Do I trust that that vendor is going to maintain it over a period of time that matches the life cycle of my product, and so forth. So part of that's a design, part of that is problem solving, so part of that's software engineering best practice in terms of our degree program outcomes. Course outcome 4, students will understand and apply process knowledge to guide the transition of software artifacts across process phases. That's the contextualized version of this. And again, we use the highly iterative Scrum methodology, so you're going to learn how to track your progress, understand the cadence or rhythm of your team, and understand the notion of tracking the work effort or capacity of a team through what's called velocity, as well as your progress against requirements or building business value, which is what you use a burn down chart for. So this is part of critical thinking and decision making and again, software engineering practice. We explicitly put you in situations where you have to make a decision, and there's no one right or optimal solution. You have to make a judgment call on what's the foundation for making those decisions. That's the point of that course outcome. And then finally, course outcome 5, students collaborate on a team to overcome obstacles. This is our teamwork communication one. You'll have prior teamwork and communication courses in like SER316. It is a common thread through the software enterprise courses. Part of that learning in context isn't just the technical context and the software engineering process context, but the human context, working with others to arrive at the best solution. Again, my name is Kevin Gary. I'm the course coordinator. Course coordinators hold office hours for every session that the course is offered. Mine currently in this semester, spring of 2018, are Monday and Wednesday, 10:30 to noon, and I'm available on Zoom video conferencing for the online students. Enjoy the course.